Hello everybody and welcome back to this part 2 of Recursion lecture. And in the previous lecture we have talked about factorial and we have given an introduction to recursion, and I hope that you got very much intuition about recursion. And we have talked one definition that for in recursion we are solving the set of problem into dividing smaller instances of the same problem. Okay, so in this video we will again solve maybe one problem. It may be a two problem if the time does not exceed. Okay, so because there is time limit, I'm not able to make a 20+ minutes video. Okay, so I will make under 20 minutes it may be. Okay, so let's talk about the previous video definition, and I assume that you got from previous video because in previous video I've given a lot more intuition. And if you're new to this video, you can stay there. I will be also starting from scratch from here also. Okay, so in the previous video we have talked about one definition, which is a recursion is a method in computer science where the solution of a problem depends upon the solution on the smaller instances of the same problem. So we have our factorial problem in the previous video. So what we are doing, we are n times the n minus 1 factorial. So if we know this factorial, we can calculate the whole factorial. If we know this factorial, we can calculate the answer. Okay, so here this is the same problem and we are dividing into smaller problem. It is from the same problem, but we are dividing the smaller problem and we are just going to clap. Okay, so this is how in the previous, I'm not going to recapitulate again because if I'm going to, it will again exist 20 minutes. Okay, so I would recommend please go through previous video, as again this is small. I'm not able to, and I think that you are beginner just now again. So here what we in the previous video we are doing, we are setting the base case equals to 1. And we are return is 0 because if n equals to 0 then we return 1. Otherwise what we are doing, we are returning n times again the calling our same function factorial of n minus 1. So let's take an example for 2. We want to n equals to 2. Okay, so n is not equals to 2, 2 is not equals to 0, so 2 times the 1 factorial. And for taking out the 1 factorial, now it is waiting for 1 factorial. Now for taking out the 1 factorial, we have 1 times the 1 minus 1, which is 0 factorial. And we know the 0 factorial because we have said that if n equals to 0. Now n equals to 0, so we know the factorial of 0. So 0 factorial is 1. Okay, and now we have got a 1 factorial. Now this is waiting for 1 factorial. So 1 times the 0 factorial is 1. So 1 times 1 equals to 1. So it is waiting, so we will give 1, and 2 times 1 equals to 2. Okay, so this is the 2 factorial equals to 2. This is how it works because one function waits for the another to solve the problem, and another should wait until and unless we reach out to the base case. Okay, this is how it works. And in this video we'll again solve one problem, which is a sum of natural numbers till n. Okay, so what we have to do, we have to take input from the user, like let's say 5, and we have to 1 plus 2 plus 3 plus 4 plus 5, and we want to give the criteria. I'm not going to do the addition just now. Let's do the addition. 3 plus 2 6, 6 plus 4 10, and it's 15. The answer is 15. Okay, so the answer should be 15 using recursion. Okay, you can do with a for loop or a while loop or any kind of loop, but using a recursion. Okay, so what is the procedure? What is the logic for that? So we want 1 plus 2 plus 3 plus 4 plus 5 all the way down to the n minus 1 plus n. So this is the logic we have built, is that we have to go from 1 to the n minus 1 and then we will add n to that. It simply means that let's say we have sum equals to 4. I want to take sum of 5, means 1 2 3 4 plus 5. So if we know sum of 4, let's say 4, we can simply add 1 to that and we can simply get sum of 5. Okay, so just like this we have built one logic n minus 1 because it is going from 1 to n minus 1 and then we will add n to it. you will understand if you go further, your logic will eventually grow up. Okay, so how do we write the code for this? And again, the base case here, the base case is if n equals to 1, if n is equals to 1, then we return 1, because we know that n is if 1 is eventually equals to 1. Okay, so let's write the code of that. So for that, let's write a sum function which takes an integer and as an input, and what it does, it checks if the n is equals to 1. If it is, then it will return 1, otherwise it will return the n minus 1 plus n. It is calling sum of n minus 1 plus n. It is calling its own function n minus 1 plus n. So let's understand in a little bit more intuitive way. Okay, so let's take an example that n equals to 4. Okay, so we have n equals to 4. Now 4 is not equals to 0, 1, let's say 1. Okay, so it is not equals to 1. Okay, so what it will return, it will go on to the else. So sum of n minus 1, so sum of 4 minus 1 plus n. So sum of 4 minus 1 equals to 3 plus 4, this is 4. So it is waiting for sum of 3. So it is now waiting, now it is paused. Now it is paused. Now it is waiting for sum of 3. And again sum of 3 will go up, and we'll check sum of, it is 3 is equals to 1, no. So we will again go here, sum of 3 minus 1 equals to 2, plus now n is equal to 3. Now n equals to 3 because we are here, it is 3. So now it is calling this another function, but it is the same function. Okay, so n equals to 3. Now it wants sum of 2. Now n is equals to 2. Because the sum of 2 here, n equals to 2. Now it checks, is 2 equals to 1? No. Then it will go in else. So sum of 1, 2 minus 1 equals to 1 plus 2. Now we know that here n is equals to 1. N is equals to 1. Now this is the base case. This is the base case that we know, that n equals to 1. Now this will return 1. This will return the sum of 1 equals to 1 plus 2. So we know that sum of 1 equals to 3. Okay, so we know that sum of 1 equals to, let's say, 1. I think it's a sum of 1 equals to 1 plus 1. Yeah, so it will be here, it is waiting for sum of 1. So it will return, it will go up, and the sum of 1 is 1. The sum of 1 is 1, and then, and you can think what is it, just I think you're confused just now after I removed this, because you might become it might be confusing to you. So we know that sum of 1 equals to 1. So here 1 plus 2 equals to 3. Okay, so we got sum of 2. Sum of 2. Now this is waiting for sum of 2. Now we have 3. So sum of 2 equals to 3. 3 plus 3, 6. Okay, so we now got sum of, now we got sum of 3. Now we got sum of 3. Now this is waiting. Now sum of 4 is waiting for sum of 3. Now we will give to them, and then we will add 6 plus 4, which is equals to 10. This is how all the procedure works, and pretty much easy to understand. Pretty much easy to understand what is happening there. Again, I'm going to explain you just a quick recap. If n is equals to 1, we will return 1, else we will return the n minus 1, taking again the sum plus n. Okay, and again let's take an example, n equals to 2. Okay, very short. Now 2 is not equals to 1, so it's sum of, here is we want sum of 2. So sum of n minus 1, which is 1 plus 2. Now n equals to 2, no. So sum of 1 we know is sum 1, n equals to 1. So 1 plus 2 gives us 3. This is waiting for sum of 2. Okay, so this is how all it works. Let's code that a little bit more faster way. I'm on my package, and let me make a class here. Let's call this as a sum till n, and I will public static finish. Okay, so let me remove this one from here. Okay, so what you have to do, you have to simply make a function public static integer, and it is sum till n. I think my spelling is wrong. Okay, so it takes input as a num, and what it checks, if the num is equals to 1, then what it return? It return 1. Okay, else it will return n, the sum of, let me add a sum till n, because the function name is sum till n, sum till n minus 1 plus n. Again, the same thing happening here. Please rewind this video and try to understand by your, since I have already explained you about this. So again, what is happening is num. So again, it is num. Okay, so what is happening? Let's say n equals to 2, n is equals to 2, so it checks 2 is not equals to 0. So it's 2 minus 1 equals to 1, but sum of 1, we know that this is the base case, so it returns 1. Now sum of 2 is waiting, so it gives us sum of 2 and then add it up, and then we got the result. So this is how all the recursion is, and I hope that you got better intuition. Let's run this out for a little bit more intuitive way. So I will make this as a, let's say 4. Okay, so I think it should give at least 10. Okay, so we got 10. This is how the problem statement is. A very easy problem. Okay, so this is 12 minutes, so let's solve one more coding problem. So the coding problem is x to the power n. So what is that? So what is this? Let's try to understand it a little bit in a more intuitive way. So x to the power of n. So let's say you want to take the x 3 to the power of 4. Okay, so if we know 3 to the power 3, and if we multiply it by 3, we will get 3 to the power 4. And you can see here that this is the 3n minus 1 times the n. So this is n minus 1 times the n, or I can write n times the n minus 1. How we build the logic? We set it up an example and we assume that what is happening, what is the relationship, and then we got this as a formula for the recursion. Pretty much easy. So now let's write a code for it, as a dry code. So pow, I will write pow. It takes integer x, so x here is, let's say 3, and integer n is the exponent power here, so n, and the base case is if 3 to the power 0, it will return 0. So if n to the power 0, it will return 1. Okay, so you know that in exponential power that the power of any number 0 is equals to 1. So if here, this is the power here, so if n is equals to 0, then it will return 1. Okay, and this is the base case. Okay, and this is where we terminate, we did not recur. Otherwise, if it is not, then we will return, we have just made a logic, the power of x comma n minus 1 times the n, or we can put n here, and this is the same way. Okay, so let's try to understand in a little bit more intuitive way for a simple example. Let's take an example that we have. Let me remove this, and let's say we have our favorite, let's say x equals to 3, and n equals to 2. Okay, 3 to the power 2. Okay, so see here that the 2 is not equals to 0. Okay, so it goes on return, so it's calls the function. Now if it's calls the function here, 3 comma 1 times the n, power of 3 comma 1. So now we want the power of 3 comma 1, and it is waiting, so we again go up, and here n is not equals to 0. So what it gives, so again power of 3 comma 0 times the 3, or you can say yeah, this is n. I think it should be, it should be not n, it should be x, because I'm a little bit confused about that. So it should be x because we are multiplying with the x. Okay, so 3 to the power 3 times this is the 3. So this is x, this is vx. Okay, and this is the n. Little bit confused about these statements. Okay, so here we are multiplying with x, and again we know that n equals to 0. Now it will return the power of 3 comma 1. So we will give out to this. Now we know that this is equals to 1, so it gives us, now this is also 3. Now it will take out this, it will multiply. Now we know the 3 comma 1 equals to 1. 1 times the 3 equals to 3, and then it goes up and do the same process, and it goes. Because I've already explained it, I'm not going to explain you once again, but this is all how it works. That we have a base case, and then we check, and one function waits for other to be solved, and other to be solved wait for until and unless it reaches the base case. Okay, so let's code it below. Let's code it a little bit more faster way. My Eclipse, and let me make a class, and let's make a power, and I will base a template. Okay, so I will public static integer, and this is a pow, and it takes integer x comma integer n, and you can optimize it o log n. We'll talk about optimizing it later, not just now, because it's just a recursion. I'm not going to talk about it. This just now, we'll talk about it later on. Okay, so if the base case is f n is equals to 0, or let's say 0, let's say 0, then it will return, this is the base case, so then it will return. Otherwise it will return the, let's say, x times the power of x comma n minus 1. Okay, so this is how all it works, and let me call my function. So system dot out dot println, I will call my function, and it takes input as a, let's say, 3 to the power 4. So let me save this, let me run this, and this is giving me 81, which is the absolutely correct answer. Because a very easy approach, and I hope that you will be also solving problems, as again I am noting here that problems, let me write here that coding problems is given in notes, because I am explaining in the notes also. So notes, my LinkedIn, I think spelling is correct, yeah, my Instagram, all the things are updated there only. Okay, so this is already 18 minutes, and I hope that you got better intuition about recursion, and please solve the coding problems. And the next video we'll go to a little bit advanced concept like a tower finite problem, kind of very advanced concept. It may be a 3 to 4 pattern recursion. We are not going to make any kind of a very much little bit doubt in your mind. Okay, so just to clear that, you should be familiar with English. Okay, so thank you for seeing this video. I'll be catching my next video. Till then, let me subscribe this YouTube channel, subscribe this YT channel, and press the notification bell. Press it. Okay, I'm not going to write more. Okay, so press the notification bell, and meet you in the next video. Till then, and bye bye.